So basically, this is the National Program on Technology Enhanced Learning (NPTEL) from January to February 2025 4-week NPTEL course. So this is the your week 1 live session. Is recent advances in transmission insulators, and course code is NOC 24 EE71. I am your teaching assistant Nida Khanam. I am a PhD scholar from Department of Electrical Engineering, Aligarh Muslim University, and my research work is on the field of distribution network state estimation, and basically I am doing research on PMU with the respective field. So here I have selected recent advances in transmission insulators for teaching assistant course. So before starting, I would like to know that how much you know about transmission systems and transmission networks and insulators. Anyone? No one?
Insulators used for transmission to avoid unnecessary flow of charge. Madam.
Okay, any other? Okay then. So basically, starting with the all sides, I would like to introduce some contents, that is introduction part, important components of transmission systems, insulation coordination, and design and selection of insulators which are based on transmission and distribution systems. So basically, transmission insulators are specialized components in power systems that support conductors and provide electrical isolation from grounded structures. Okay, these are the specialized components which is used to provide the mechanical support, electrical isolation, and environmental protection. In which form? Basically, it holds and position conductors to maintain proper alignment, and it also prevents the flow of current from live wires to grounded structures, ensuring system safety and efficiency. And it resists factors like wind, rain, pollution, and extreme temperatures to maintain operational stability. Okay. So basically these are the development of transmission voltages. So here we see that this graph shows you the growth of development of the power transmission across the globe, that is across the world, where you set at an increasing about 3% per year. That is, the voltage as the transmission voltage has been seen increasing since 1900. Okay. So presently we are in the country operating at 765 kilovolt levels, and at 1200 kilovolt level experimentations is also in progress. So there is an importance of advancement because of we require higher voltage levels, because at transmission voltage increases up to 1200 kilovolt, traditional insulators need improvements to handle higher electrical stresses. Second is environmental challenges. As we all know that advanced designs are crucial to counter issues like pollution, icing, and UV radiations in diverse climates. And also modern insulators focus on eco-friendly materials and improve durability to reduce maintenance and environmental impact. So there is a need of importance of advancement of transmission insulators. So there are some transmission technology which is starting since 1977. So this graph shows the how the transmission technology which is developed in the country. So this graph shows since 1977, where we were operating at 220 kilovolts. It gradually gradually 90s we were operating about 400 kilovolt. Okay. So further in 2000 we started using HVDC. Okay. Prior to that we were using HVDC, but to an extent. In 2000 we use 2500 kilovolt HVDC, and because HVDC is much more beneficial for long distance transmission, where the huge power can be transmitted over a long distances. So this is the one of the major advantage of going in for HVDC presently in the country. We have several lines which are operating at 500 kilovolt, and also we have 800 kilovolt HVDC lines, which is the world's longest multi-terminal HVDC to harness renewable hydropower from northeast, that is from Arunachal to Agra. Okay, so presently we are towards the AC side, and we are operating several 765 kilovolt transmission lines HVDC, and we are at 800 kilovolt transmission systems in operation. So the transmission, when you look into the transmission standard operating voltage across the globe, so the voltage adopted for the transmission, particularly for the bulk power, have to conform to the standard specification, that is some nominal system voltage and some maximum operating voltage. That means, so the voltages which are being transmitted to are considered as nominal system voltage, that is that is in India, as per the Indian standards, line to line voltage is adopted as for the following. We have nominal system voltage and also maximum operating voltage. So the nominal system voltages are shown for 132 kilovolt, the maximum operating voltage is 145 kilovolts, and similarly for 220 kilovolt, the maximum operating voltage is 245 kilovolt, and for 400 kilovolt it is 420 kilovolt, and for 760 kilovolt it is the maximum operating voltage is 800 kilovolt. So similarly for 1200, the maximum operating voltage is nominal voltage is 1150. Why we are choosing maximum operating voltage? Because the insulation levels of equipments based upon maximum operating voltage, and if we go beyond the maximum operating voltage, then insulation failures occurs of all the equipments or any part of the system. So the equipment will not able to perform at the proper operation. Okay, so this table shows the power intensity in megawatt per meter at different voltage level. So when you look into this graph, this chart is presented here, that gives a very clear idea of the power intensity in megawatt megawatt per meter for different voltage levels. Okay, so for 132 kilovolt or the system, what should be the right of way? That is the tower, the clearance from the tower clearance. What is right of way? Anyone knows? Okay, so this is the distance between the tower midpoint to either side. So the right of way per 132 kilovolts system is 27 meters, and what could be the capacity which it can transfer the power? It seems between 70 to 80 megawatt. Okay, so if you look, the voltage level is continuously increasing, the right of way is also increasing. Okay, okay, for the voltage level 760 kilowatt, the right of way is 64 meter, and the capacity that is used for transferring the power, it is in between 2500 to 3000 megawatt. Okay, so that is how the conductor configuration is being done, and this graph shows the power capacity at different voltage levels, and what will be the right of way in meters, and how much capacity it can transfer at up to what voltage levels. Okay, this is the basic criteria at which the transmission insulators are designed for different voltage levels. Okay, so now we will discuss the key components of transmission systems. So basically there are five major key points which are the main components of the transmission system. First is insulators, next is conductors, third one is towers and foundations, and earth wires, last is hardware fittings and accessories. So these components in the transmission systems are mentioned here. So when you have the main components is first is insulators. Insulators provides the mechanical support for conductors, and it ensures the electrical isolation between conductors and grounded structures, and it plays a critical role in operational reliability and system safety. And when you all of you knows about the conductors, because the number of free electrons is very high in conductors, and it carry high voltage electricity over long distances, and it is made from the materials like aluminum or aluminum alloy for optimal conductivity and weight balance. So next is towers. Tower is used for structural supports that that maintain proper spacing between conductors to prevent arcing, and it is used to design to withstand the environmental stresses like wind, ice, earthquakes, and next is substations. Substations serve as the hubs of our voltage transformation, switching, and control, and it also enable integration and integration distribution of electricity in various grid. So these are the some key components of the transmission system which are used for transferring the electricity. So the next is insulation coordination. Have you ever heard about insulation coordination? What is the main concept behind it? Anyone? So insulation coordination, it is the process of designing and selecting insulation levels. That means at what criteria you are selecting the insulation levels to ensure the safe and reliable operation of electrical systems, and it protects equipment from over voltages which are caused by lightning, switching surges, or any type of faults, and it also ensures the system reliability by minimizing risk of insulation breakdown, and its main objective is it provides a safe operation. That means it prevents dielectric failure of insulators and equipments, and it is used for give the balance between the cost and insulation performance, and in environmental adaptation it also addresses the challenges like pollution, humidity, and temperature variations. Okay, so insulation coordination is the process of designing and selecting insulation levels to for a reliable operation. So there are some methods for insulation coordination. So first, the first method is based on system voltage. That means according to nominal voltage and maximum operating voltage, we choose the insulation levels. Okay. So when second scenario is over voltage scenario, that is we choose transient over voltages, switching surges. So based on this, we choose the insulation coordination also. Now next is environmental factors play a very important role for selecting the insulation coordination, like everywhere is everyone knows about the pollution. So highly populated area, pollution is more, so we use pollution resistant insulators in contaminated areas, and if we go higher altitude areas like where the air density is very low, so we use lower insulation strength area. So according to that we select the insulation coordination, and last is weather. So depending upon the extreme weather condition, like somewhere is happening heavy rain and somewhere is snow. So depending upon the extreme weather, depending upon the weather condition, we choose the insulation level. So last is electrical stress. So determining the appropriate creepage distance. What is creepage distance? Anyone? No. So creepage distance is that distance which is the distance from the surface of the insulators to the conducting parts of the material is known as creepage distance. So for determining the appropriate creepage distance to withstand surface discharges, and it also minimizes the corona discharge in high voltage systems. So there are some insulation coordination standards. uh, First is international standards. So in this type of standard we use IEC 60071, and it provides principle of insulation coordinations. And the second is IEEE standard 1313.2, which is used for guide for high voltage insulation coordination. And now second is the tool we are using for insulation coordination is EMTP, that is electromagnetic transients program for over voltage analysis. And also we do the experiments in high voltage laboratories uh, watching the performance of insulating materials in breakdown of oil, when breakdown of oil occurs, and when the transmission flashover occurs. Okay, for this purpose we are having the high voltage testing laboratories for watching the insulation performance evaluation. So there is the history behind the transmission insulators. So basically it is, it starts in late 1700, or you can say early 1800. So basically it grew out of needs of telegraph industry. So during that time it started the need of transmission insulators. Then during 1840 to 50s we were using glass plates to insulate telegraph lines. Okay, so several trials with different materials such as wood, cement, porcelain, beeswax, etc. are used for that purpose, and ultimately porcelain and glass prevailed. After that, during 1902 to 1920s, there are some applications of voltages increases. Then insulator designs become more and more complex. Still, ceramics are only that choices at high voltage time, high voltage. So in 1907, Harold and Edward invented the disc insulators. So during that time, during 1970s to present, non-ceramic, that is composite insulators industry begins in US with the field trials of insulators. So these are the history of transmission insulators, which is started in late 1700, and till now we are using non-ceramic, that is composite insulators. Okay, so we have already known that there are basically four types of insulators, that is suspension insulators, strain insulators, pin type insulators, and post insulators. So basically suspension insulators is designed for the series of porcelain or glass discs which are connected, excuse me, it is the series of porcelain or glass discs connected in to form a string. Okay, all the discs are made for 11 kilovolt disc, and these are used for high voltage transmission lines, or you can use it for long spans in overhead lines, and because it provides the high mechanical strength and flexibility for varying line tensions. Okay, next insulators is strain insulators. It is similar to suspension insulators, but it is designed to handle greater mechanical stress. Like it, we can use it like termination points where sharp angles in transmission lines or supporting heavy mechanical loads at angle points are used, and it is very excellent. It has very excellent tensile strength for heavy loads. Okay, now pin type insulators, we all know that it is a single piece insulators mounted directly on a string, and main advantage of this is it's a compact design, high mechanical and electrical strength, and it provides a supporting structure. Okay, the for low to medium voltage, I think up to 11 kilovolt it is used, and for compact low voltage distribution lines it is made for this. And the main advantage of pin type insulator is it's simpler in installation, and suitable for shorter spans. Okay, for small distances. Now the next is post insulators. Post insulators design is cylindrical or columnar structure which is mounted vertically or horizontally. Okay, so the main applications of post insulator is in substations and switch gear applications, or there. Okay, uh, now there are some materials which are having some advantages and disadvantages which are used as insulators, like porcelain. Porcelain is having very high mechanical strength, and it has a very excellent resistance to UV and aging, but it is very heavier. it is prone to cracking under mechanical impact. Okay, it is not able to bear more stress. So the next is this glass. Glass is having higher dielectric strength and its self-healing properties for surface defects, but the main disadvantage is it's very fragile, that is limited resistance to vandalism. Now next material is polymer, and as we know that polymer is very lightweight, and it is resistant to pollution, and it's very flexible in design. But the main disadvantage of this is it is susceptible to aging under UV radiation and weathering, and less proven long term performance. So there are some advancement in materials for insulator, like we are shifting from porcelain and glass to polymers, because ceramic or porcelain insulators were used in since 1830s, when telegraph lines begins, and it is used at all voltages for line insulation, and it provides a greater flexibility, and it is strong in compression, it's available in various shapes, and it is having high degree of standardization. But these insulators, and due to their mechanical strength and electrical insulating properties, it is now going to obsolete. So recent trends have seen a shift toward polymer based insulators, uh, which offer advantages like lightweight design, increased flexibility, and better durability in extreme weather conditions. So next is enhanced hydrophobicity and self-cleaning properties. So, so polymer insulators now featured enhanced hydrophobic properties, which significantly reduces water retention, and development of self-cleaning surfaces prevents the accumulation of dirt, dust, and contaminates, ensuring the insulators maintain their performance over time. Next is composite insulators we are using with improved performance, like it's a type of hybrid of polymer and fiberglass insulators, and it offers superior mechanical strength and electrical insulation properties. These insulators are especially effective under contaminated or harsh environment conditions, like heavy rainfall, high pollution levels, and it also offers improved performance and reduced maintenance cost. So at what are the criteria, at what basis we are designing and selecting the insulators? So basically we see the voltage rating, mechanical load, and pollution levels. On the basis of this, first criteria is parameter selection, that on the basis of these we select the insulator and design the insulators. Now the next criteria, we choose the coastal and desert industrial zone, and based on these environmental conditions we select the insulators. So next is advances in computational modeling for stress and performance analysis. We see their how they perform in extreme stress condition or performance analysis, and we use the AI techniques in predictive maintenance and for designing purpose. So still there are some challenges in transmission insulation. So first is very common challenge, that is environmental challenge, and second is electrical challenge, and third is mechanical challenge. So in environmental challenge we see the pollution. So the main impact which comes from industrial emissions, salt deposits in coastal areas, and dust particles that can settle on insulators, and it causes contamination and reduces their effectiveness, and this can lead to flashovers, reduce insulation life, and frequent maintenance requirements. So how to mitigate it? So we use hydrophobic coating such as RTV silicone coating we are doing, and periodic washing of insulators, cleaning purpose, and development of self cleaning insulator surfaces. So by doing this we mitigate the impact of pollution which comes for the challenges in transmission insulation. Now next is ice acceleration. So in cold regions we see that ice formation on insulators, it increases their weight, and which can cause mechanical stress, leading to potential damage or line sagging, and ice also creates uneven voltage distribution, increasing the risk of flashovers. So we design insulators with anti-icing coatings. Okay, we do anti-icing coatings on them, and it we employs it heating elements and using composite materials to for resistant to ice buildup. Okay, now next is UV degradation. Due to UV degradation, it prolonged exposure to ultraviolet radiation from the sun degrades polymer materials in insulators, so leading to cracking or surface erosion and loss of mechanical strength. And the main so we can mitigate it, but by using the UV resistant materials, by adding some stabilizer to polymer insulators, and employing regular monitoring to detect early signs of degradation. Okay, these are the environmental challenge, and the techniques how we mitigate the impact of these challenges. Now let's see the electrical challenges. What are that? So first of all, we say that high voltage surges. So due to that, the impact of high voltage surges, lightning strikes, switching operations or faults, it all can generate high voltage surges which may exceed the design limits of insulators and causing breakdown or puncture. So, okay, we can also mitigate it by installing surge arresters or designing insulators with higher voltage withstand capacity, and improving grounding systems. Okay, and second, the main challenge is arc flash risk. So when high voltage travels through air gaps due to insulation failure, an arc flash can occur. Okay, and that is known as corona. We all know that. Okay, leading to damage to equipments and hazards to maintenance personnel and network outages. So to mitigate it, we use proper spacing of insulators, and designing insulation system to handle higher fault currents, and adopting arc resistant coatings or shields. So last is mechanical challenges. So in this we see that load bearing. Load bearing means insulator must support the weight of conductors. Okay, and additional loads such as snow or ice, so because of that overloading can occur. So because of overloading, mechanical failures or insulator breakage can occur. So by using high strength materials like composite insulators or polymer with glass, we can optimize it. Okay, we can optimize insulator shapes and stress relieving hardware. We can mitigate the impact of load bearing. Okay, now the next impact is wind. As we all know that in high wind speeds can also cause the oscillations in power lines, leading to dynamic mechanical loads on insulators, which may lead to fatigue failure over time. So by installing dampers to control line oscillations and designing aerodynamic profiles for insulators, it reduces the wind resistance and overcome the impact of mechanical challenges. So third is the seismic resistance. Seismic resistance is due to the earthquake. Earthquake Earthquakes can impose sudden and significant stress on transmission towers and their insulation components, and risking damage and outages. So by designing insulators and support structures with sufficient flexibility and strength to withstand the seismic forces, so we can design by this type of insulator to give to give a strength to mitigate this seismic resistance, so we can overcome these challenges. So there are some strategies to address these challenges. First of all, we use the advanced design like development of hybrid insulators that as I told earlier, that polymer with glass or polymer with ceramic properties, it improves the performance, and designing modular insulators for easy replacement and maintenance. And we can use advanced materials like silicone, rubber, epoxy resin, and other composite materials for better mechanical strength and electrical performance and resistance to environmental stress. Okay, also we can use the nanotechnology material to enhance the material properties such as self healing and self cleaning capabilities. So next is preventive maintenance. So regular monitoring using drone inspections or thermal imaging and condition assessment tools, and predictive maintenance using AI techniques or machine learning for fault detection and trend analysis. Now the last is smart insulation. So development of sensors, today we are integrating sensors to the insulator for real time monitoring of temperature, humidity, and contamination levels. So IoT based enabled system like Internet of Things enabled system for remote diagnostic and early warning of potential failures can overcome these challenges and provide the better criteria. So there are some future trends and innovations which are being used in today's scenario, like smart insulators with the embedded sensors for real time monitoring, and second is development of 3D printed insulators for custom applications, and third is enhanced recycling techniques for sustainable disposal, and fourth one is applications of AI and machine learning in predictive analysis and design optimizations. These are the future trends and innovations which are being used in today's scenario. So the main key advancement in this presentation is the summary of the key advancement in transmission insulators, how the importance of addressing environmental and operational challenges can occur, and what are the future outlook which emphasizes the sustainability and smart technology can be built with the insulators. So depending on these presentations, I have some objective questions which you have to solve. Okay. Again, you have to see any slides from this, then you can ask me. Okay. So now let's start with objective questions. What you have learned from this presentation? So the first question is, what is the primary role of transmission insulators? First is conducting electricity, supporting conductors and ensuring electrical isolation, reducing power losses, and connecting substations. Anyone can answer, okay? No one? So it's used, the primary role of transmission insulator is it is used for supporting conductors and ensuring electrical isolation. Okay, the next question is, which of the following factors has driven advancement in transmission insulators? The first option is reduction in power generation cost. Second is higher voltages, increased system flexibility. Third is higher voltages and environmental challenges. Fourth is enhanced substation design. Okay, this answer is higher voltages and environmental challenges. Okay, now moving on to the next question. क्लास क्लास चल रही है. So the next question is, which of the following material is not commonly used for transmission insulators?
Aluminum.
Very good. Anyone else? No. Okay, aluminium is the correct answer. Now the next question is, which component of a transmission system supports the electrical conductors and ensures they remain at a safe distance? Substations, towers, insulators, ground wires. Which component? Okay, it is the insulators. This supports the electrical conductors and ensures they remain at a safe distance. Okay, the next question is, what is the main difference between AC and DC transmission systems regarding insulators? What is the main difference? How they are differentiated at AC DC transmission systems regarding insulators? Option A is AC systems require more robust insulators than DC systems. Second is DC systems require higher insulation levels due to constant voltage stresses. C is insulators are not required for DC systems. And D is AC systems use polymer insulators exclusively. Maharush? Who is Maharush? Are you there? Dharamveer? Dilkesh? Okay, answer is B. So DC system require higher voltage installation levels because as I discussed earlier that the transmission HVDC lines require higher operating voltage, that is nowadays 1200 kilovolt is in experimentation and 760 kilovolt is in operation. So the higher insulation level depends upon the voltage level that we have selected. Okay, so DC systems require higher insulation levels due to a constant voltage stresses. That's why this is the main difference between AC and DC transmission systems regarding insulators. More insulations required in DC. Now the which of the following is not a key component of a transmission systems? All
Generators.
very good. Where you were, Maharush? I asked you earlier. Okay,
Ma'am, I went to the washroom.
okay, okay, fine. Now, the have you seen your previous question? What is the main difference between AC and DC transmission systems regarding insulators? Have you heard?
Yes, ma'am.
Okay, what will be the answer?
Ma'am, B.
Okay, DC systems require higher insulation levels due to constant voltage stresses. Because why? Okay, because there is a tendency of transferring large amount of bulk power will be transferred from generating to transmission generation to distribution system. So large amount of insulation level requires for HVDC lines as compared to AC. This is the main difference in terms of insulators. Okay, so why we are doing insulation coordination? What is the purpose of insulation coordination? First, First is to reduce conductor sag. Second is to ensure proper insulation levels for safe operation. Third is to improve power quality. fourth is to minimize conductor weight. What would be the answer? Anyone?
A. To reduce conductor sick.
Okay. Anyone else?
B.
B. Anyone else? No. The correct answer is reducing the conductor sag. We are doing insulation coordination because of this. Now the eighth question is, which standard is widely used for insulation coordination in transmission system? एक मिनट आ रही हूँ आ रही हूँ Okay, what would be the answer of eighth question?
B.
Which standard is widely used for insulation coordination system in transmission system? IEC 60071, IEEE 519, ISO 9001, and NEMA MG1. So the correct answer is B, IEC 60071. Okay.
Yes, ma'am.
Yes.
Ma'am, can you show question number
Which? Question number which?
6?
Sixth. Okay. Yes. Which of the following is not a key component of a transmission systems? Key component.
Generators, madam.
Sorry. Generators. Okay.
Generators, madam.
Good. Good. Correct.
Ma'am,
Now,
what is the answer to question one, ma'am?
sorry. What is the
Answer.
answer? Is generators. Answer C is correct. Okay.
Okay.
Uh,
For ma'am, for question 7.
your voice is not clear. Answer is C. C answer is correct. Generator is not the key component of transmission system. The main components of conductor, insulators, transformers, towers, etc. Okay. Now the next question is, what environmental factor is not typically considered during insulation coordination?
Soil type.
Yes. Anyone else? Soil type, you said D.
Yes, ma'am.
Okay. Anyone else? Go there. Okay, soil type is the factor that is not typically considered during insulation coordination, and pollution levels, temperature, and altitudes are all are the main factors, environmental factors, which are being considered in insulation coordinations. Okay, what tool is often used to determine insulation levels in transmission systems? First, A is fault current studies, B is lightning and switching impulse voltage studies, C is transformer loading analysis, D is harmonic analysis.
B.
D or B?
B.
D. Harmonic analysis.
B.
No, B.
B. Anyone else? Yes, lightning and switching impulse voltage tool is often used to determine insulation levels in transmission systems. Okay. Next question is, which type of insulator is most suitable for supporting long spans of transmission lines under high mechanical loads? Which type of insulator is most suitable for supporting long spans of transmission lines under high mechanical loads?
B.
It's B or D. Strain insulators or suspension?
B.
B.
A strain insulator.
Okay. Anyone else? Okay. The strain insulator, it's the most suitable for supporting the long spans of transmission lines under high mechanical loads. Correct answer is B. So the which material is preferred for insulators in high pollution environments? High pollution environments, which materials is preferred? Porcelain, polymer, glass.
Option
Answer
Polymer.
option
B. Polymer. Okay. So the next question is, what is the significant advantage of glass insulators over porcelain?
B.
B. Higher
B.
higher dielectric strength and self-healing properties.
Yes.
Okay. Anyone else?
B.
Okay. Now the last question is, so correct answer is B. Higher dielectric strength and self-healing properties. So what is the primary factor in selecting the type of insulator for a transmission line? What we see firstly, okay? The options are cost of installation, environmental condition and voltage levels, availability of materials and design of the substation.
B.
Okay, answer is
B.
B. Okay, fine. So correct option is B, environmental conditions and voltage levels. We see this factor for selecting the type of insulator for a transmission line. So all this done here. So the references we have, which I have taken for this presentations, are research papers, industry standards like IEC, IEEE and case studies. And I have also seen the comprehensive study on recent advancements in transmission insulators. And if you have any query, then you can ask me in next class, okay, regarding this. Next class would be on 4 to 6 p.m. next Sunday.
मैम क्लास का पीडीएफ कहाँ मिलेगा
सॉरी,
क्लास का पीडीएफ
क्लास का क्या?
अब का PDF
दुल्ला चुप रहो यार. Okay then, thank you so much for joining me, and this is my first session. Okay, thank you all. You can leave now.